right, welcome back to Schoology. We're looking at rates, ratios, proportions. In class, we started looking at ratios as a fraction, something over something else, a comparison of two things. So a comparison of two things, and then we looked at proportions as one method, as a way to look at which ratios are the same. We cross-multiplied as a method for solving a proportion, but it's not the only method. We're going to look at applying these ratios and proportions to real-world situations. We read a lot of real-world stuff in this chapter. So we're going to look at a rate is a comparison of two quantities like a ratio, but it's ones that have different units. And it's the different units that makes the difference between a rate and a ratio. So I'm going to write this down. A ratio would be like 9 to 30. 9 compared to 9 to 3. 90 compared to 3 is a ratio. A rate is 90 miles to 3 hours. So a rate is how fast you're going, or how often something happens, or how many students to teachers. What's the student to teacher rate? And that has a label on it. So a ratio is just two numbers. A rate has a label that goes with it. Big part of this chapter is going to be labeling. You will get points for labeling in this half of the chapter. Up until now, I have not counted any points off if you haven't put the dollar sign, or if you haven't put the word videos or something after the answer. This chapter, it makes a bigger difference because we're talking about rates, and labels make a difference. Okay, so specific types of rates. One specific type of rate is what's called a unit rate. So unit rates are rates in which the second quantity is 1. An example is that 90 to 3. So that 90 miles to 3 hours rate. We can simplify that. Most people don't say I'm driving 90 miles in 3 hours. That's just not how we talk about speed. We would say that our unit rate is 30 miles per hour. There's a couple ways to do that. One way is to set it up as a proportion, as they have it here, and say, okay, it was 90 over 3. I want the second rate, the second quantity to be 1. So how can I get there? Well, 3 divided by 3 is 1. 90 divided by 3 is 30. So it would be 30 over 1. It would be 30 miles in 1 hour, 30 miles per hour. And that's how we can get that unit rate. You can certainly set it up as a proportion and cross-multiply as well. You could say, well, it is 90 over 3. I know I want to have a 1 in the denominator there. I want to have a 1 as the second unit. I have an x there. You could cross-multiply and divide, and you get the same result of 30 miles per 1 hour. But a unit rate is for 1 hour, and we need to get down to that 1. I find the easiest way is simply to divide by the letters in the denominator, and you'll get to that final answer. So look at an example. So it looks like Geoff, but it's actually pronounced Jeff. So Jeff can type 30 words in half a minute. How many words can he type in 1 minute? So we're looking for that unit rate. So I'm going to set up my rate, 30 words. I'm going to use W for words, in half of a minute. Now, we can use calculators in this chapter now. Second half of chapter 2, we're going to start to use those calculators. Calculators don't like fractions as much. They don't work well with fractions. They work really well with decimals. So half, I could write it as half a minute, like that. However, because I'm going to be using calculators in this chapter, I might want to change that to a decimal. Say 0.5 minutes. So 30 words in half a minute. If I want to get a unit rate where there's a 1, that's supposed to be an M-I-N, there we go. If I want to get a 1 in the bottom, I got to get there somehow. So we could do, well, a half divided by a half is 1. Anything divided by itself is 1. So we can divide by a half. You could also say, well, I know that a half times 2 is 1. 2 halves makes 1 whole. So 30 times 2, 60 words per 1 minute. And again, I'm labeling. 60 words per 1 minute. You do need to have a label, words in 1 minute. All right, so I'm going to try this one. Penelope, see if you can figure out how many words per minute she types. Go ahead and pause it. Try this on your own. I'm assuming you pause it. I'm assuming you try it on your own. Again, you should have some work shown. Don't just write the answer. I know some of you know it already, but we're building into more complicated problems. Practice showing the work. the answer in the end should be 45 words, and again, labeling per 1 minute. If you didn't get that answer, watch the linked video. Use these proportions, these ratios, these rates is with scale factors. So scaling up a map. We don't typically have a map of Minnesota that's the same size as Minnesota. That would be a ginormous map. It would be very useless. And so we have scaled down maps where 1 inch on the map might mean, in this case, 18 miles in the real world. So 1 inch to 18 miles is a rate. And in these problems, when they give you a map as a scale of 1 inch to 18 miles, we have that rate. I'm going to set that up as a fraction. 1 inch is the same as 18 miles. So that's my comparison. That's my rate. That's my ratio. I want to know that, since on the map, the distance from Chicago to Evanston is 0.625 inches. What is the actual distance? So I know that on the map, we've got 0.625 inches. If I look at my rate here, the inches is in the numerator. The inches in the numerator. So when I set up my second proportion, I know that 1 inch is the same as 18 miles. I want to know what 0.625 inches is in miles. So my question is, how many miles is that? By setting up the proportion, I have a way of solving this. I have a way of figuring it out. So I'm going to cross multiply. That's not the only thing you can do. You can figure out other ways to figure out this answer besides cross multiplying. But I'm going to use cross multiplying to find the answer. I'm going to do 18 times 0.625, and I'm going to get 11.25 equals 1 times x is just x. So I don't have to worry about dividing anything. So I get 11.25 as my answer, but I do need to label it. The question is, what is the actual distance from these two cities? The actual distance is not going to be 11.25 inches. That's not how far away Chicago and Evanston are in the real world. So be careful with your labels. Labels do make a difference. Inches are different than miles, although a lot different. So 11.25 miles is the actual distance. And we do need to label for the very same reason. It's not inches, it's miles. And that's how we can use this proportion to answer the question. Try this on your own, similar idea, set up the problem, set up a proportion, use that scale that they're giving you to figure out on the map how far Chicago is to Waukegan. I'm assuming you paused it. I'm assuming you tried it on your own. The correct answer for this one is that the distance on the map is going to be 0.2 inches. It does say round to the nearest tenth, and so 0.2 inches is how far it is on the map. If you didn't get that answer, watch the linked video so we know how to do it when we get to class. Okay? That's it? Oh, no, I apologize. There's one more thing. Unit rates. We did already talk about unit rates, and we had some questions with Penelope and Jeff. There's one specific type of question I want to look at, and that's when you're dealing with dollars. So if we have 3 for $5, let's say 3 pizzas, or maybe apples, we're both apples, 3 apples for $5. So that's what it is in the store, 3 apples for $5. When you're setting up these unit rates, and you're trying to figure out what the unit rate is, if we set it up this way, 3 apples for $5, and we figure out the unit rate this way, we divide by 5, 5 divided by 5 is 1, 3 divided by 5 is going to be 0.6. Most grocery stores will not let you buy 0.6 apples for $1. That just doesn't happen in the real world. And so you have to be very careful with these dollar amounts. When you're doing the dollar questions, we don't put the dollars in the denominator. We always put the dollars in the numerator. Because it doesn't matter if they're talking about pizzas or socks or peppers or whatever, you can't buy part of a pepper. They just won't let you. You have to buy the whole thing. You don't have to take the whole thing with you out of the store, but you have to buy the whole thing. They're going to charge you for the whole apple, even if you eat some in the store and only take 0.6 with you. You have to buy the whole thing. And so when you're setting up these dollar amount ones, always put the dollars on top. Dollars are the king. They win everything. They're always on top. So now if we divide by 3, we're going to have a unit rate. 5 divided by 3 is going to be what, 1.6 repeating, so $1.66, $1.67 if you round it up, I suppose. I do my arithmetic right there, yeah. And so we have 7 for $10. Give this one a try. See if you can get the unit rate for this one. I'm assuming you paused it. I'm assuming you tried it on your own. If we set this one up, and again, it's dollars, so I'm going to round to the nearest penny. We should have $1.43 for 1 unit, whatever we're talking about. If you didn't get that answer, click on the linked video. Okay, that's all I've got for this one, and good luck on the post question.